Welcome back to part 2 of our Hoverboard for Robotics series. In the last episode, we covered some overall details of the hardware of a hoverboard and how we can use that, from mounting the wheels to a little bit of the wiring, and how you can use the actual chassis of the hoverboard itself as part of your creation. In this video, we're going to cover a lot more details about the control board itself and the tools you need to flash the firmware, so you'll be able to make your own creations that respond to the control devices you designate. Let's not waste any more time and get right to it. A quick look over the board. I know it has a lot of spaghetti and it looks intimidating, but it's really not. Let me move some of these out of the way. And again, I didn't discover any of this. Everything I know I learned from the tutorial from Nicholas Foth, as well as Emmanuel Ferrou in the documentation in his firmware. So just going around the connectors that we need to worry about. First, this large one, this XT60, is the main power connector. That's where our battery goes. And we are looking for a 36-volt battery. According to Nicholas Foth, these can handle more than that, but I have not tried it, and I just don't see a need to. At 36 volts, this thing can pull my truck around all day long, so I'm quite happy there. And for robotics, they don't need more speed. This connector, I think, was just connected to some LED lights. It's not an important connector that we need to worry about. On both the right and left side of the board, we have these connectors that go to the motors, and that's pretty handy that they're color-coded. They all seem to have the same color code, so regardless of the brand of motor, they seem to work interoperably. This ribbon cable here is something that you won't find. What you're actually going to find is 4 programming holes right next to the main chip here, and I soldered this in, leaving myself a little bit of extra room. One little note is that I regretted trying to solder wires directly into the board. The holes are very tiny and it's very tight spaces in there, and I had a much harder time soldering wires in than on this other board. You can see I just soldered in a header. That just took a few seconds. Getting all these wires in and getting every little hair, every conductor out of the way, yeah, I don't recommend. I should have just done a header and an extension cable. Lesson learned. Coming to the other side of the board, we have more motor connections. Right, for the other motor, it's a little bit longer because it goes to the other side of the hoverboard. So these two connectors in the middle, with these quick connects, those go to the Hall effect sensors that are on the hoverboard motors. So just left and right. That's easy. Just keep those and plug those in. And then these other connectors are pretty important to us. These used to go to the little sideboards, the boards with the accelerometers in them, and we are likely not going to use them like that. We are going to use them for our inputs. And with both of these, we can set them up to take a variety of different inputs, like potentiometers, which is what we're going to use in one of our next tutorials, to control this thing with a joystick. They will also take serial data from an Arduino or a Raspberry Pi, as well as PWM or PPM for like RC control, that kind of thing. Now, the most important thing to know about these is there is one major difference. Well, they have different capabilities, and that data is in the firmware. I'm not going to get into all of that, but I do want to stress that the left, this left header can only take 3.3 volt data. So if you want to use an Arduino with serial or some such thing, you need to use the one on the right, because that can tolerate 5 volts, and it works with 3.3 or 5 volts. I've been doing both. And I'll show you how to wire those up for our purposes. But again, the full pinout and more information about all of this is available between the video by Nicholas Foth and on the firmware page from Emmanuel Ferrou. Wiring these up is pretty easy. I probably don't need to say it, but I'll say leave this big chunk of aluminum on the back. That's a heat sink. That's going to be pretty important, as all these transistors are going to kick off a lot of heat. So wiring up to the motors, we're just going to match up the colored wires. And you can't plug in the Hall sensors the wrong way. just make sure you plug them. My mistake. As I was saying, make sure you plug the left to the left and the right to the right motor. You don't get those backwards. There, that's all plugged in. Now the only thing left to do for this video is to plug in a battery and do some programming. Okay, now let's talk about flashing the firmware. This is not too different than uploading some code to an Arduino. Well, most of the works I understand are based on the work by Nicholas Voth. That's not the one I want to install. Although I do highly recommend checking out his GitHub for some information. And also make sure you take the time to watch a YouTube video he has. But yeah, these guys, young guys, they did some great work. But there's a lot of details about the hardware, your options, what these things are capable of, and different things you can do with the hoverboards. But I like to use one of two forks. We're going to start with this fork here, and if we're going to use Ross Robotics, we'll use a fork of this that I will show you in the next video. And there's a very specific reason why I like the fork that I'm going to recommend for robotics in the next video. But if you're going to do something joystick control, and just in general, how to program an STM controller, and in particular this hoverboard controller, let's clone this repository. We'll just copy here. And then I'll just do it right here. Alright, now that we've cloned, let's open it in your favorite editor. Okay, so the first and only thing you really need to worry about changing is here in the include folder is a file called config.h. And this is where you're going to set some variations for how you want this board to operate when you're done. We want to define variant useart, and as you can see it, I'm going to put it right there. The other options that you can get this board to respond to ADC, and that's something if you want to use a pair of potentiometers or a joystick, and I'm going to do that in another tutorial. But you can also use a Wii Nunchuck, a PPM or PWM if you're operating with RC controllers or such. I2C, and there's some specific modes and behaviors that you can read about in the documentation for this firmware. So we want to first define the variant useart. There's a section called Do Not Touch Settings, and I have not touched them, so I don't know what they do. I haven't needed this board variant, but yeah, apparently there's another board where if things don't work right, maybe try changing that to a 1, and that'll make sure all the pins are mapped correctly. You can calibrate your battery. We're not going to worry about those details now. Some temperature warning stuff. You can read these details about the motor control and how it's done. The only thing that I've tested is the speed mode. In speed mode, when the desired speed is set to 0, the robot will actively resist being pushed around. So that is pretty great. And some of these other modes, I believe torque mode is something where when the desired speed is set to 0, the robot or machine, if you're riding on it, would freewheel more like a car. If you take your foot off the gas, it kind of keeps coasting. So you can read more about those here, but we're going to make sure we're in speed mode 2. So we're just going to change the control mode required. For the control type selection, we can leave it in FOC. Oh, and I should stress, this is something that caught me the first time I tried to use this, is you have to have both motors hooked up to the board, or the board won't try to work and you'll think something went wrong. Yeah, the firmware is actively looking to make sure both motors are connected before it tries to do anything. Although if you comment them out, apparently you can control just one motor at a time. Again, that's something I haven't done. And then there's some other little settings that you can tweak if you want to, whether it's going to beep or not when it's going in reverse, how many minutes of inactivity until the board powers itself off, that kind of thing. Now there is a lot of code in this file, but you don't need to worry about the vast majority of it. For instance, debug mode is something you can read about, but we don't need to do anything with it. But it could be helpful. here, variant Adc settings. So we only need to worry about these sections if that's the mode that we're choosing. So later when we're choosing variant Adc in the next video, one of the next two videos, then we'll worry about this section. We chose right now the variant USART, so we're going to look at these settings. Now, remember when I said we have two possible places that we can input using the sideboard serial connections. And the one on the left is called USART2, and the one on the right is called USART3. Now, I like to comment out the USART2 and uncomment control serial USART3 and define feedback serial USART3. So we're using the same side for both sending data to the board and getting some data back from the board. I choose USART3 particularly when I'm going to use serial because it's tolerant for 5 volts, which means if I want to slip an Arduino in there, that'll be okay, or a Raspberry Pi. It just gives you the options. It works on 3.3 or 5 volts. And I believe that is the only changes we have to make, those 4 things, where we define variant USART, and then we define the control serial for USART3 and the feedback serial for USART3. The rest of these are for the other variants, and again, we don't have to worry about them. And then I believe we get to the end of the code. That is a possibility. If you're having a hard time losing bytes, whatever, with your serial, you could try slowing it down. I have not had to, but if you're using longer wires, that may be a thing you could consider. And the rest is a bunch of checks that the firmware will run on itself. So I'm just going to click Control S to save. And to do the programming, you're going to need an ST-Link V2 programmer module. You can read that. I got this on Amazon for about $10. Maybe it was only 7. I don't recall exactly. And this is a generic clone. Now, the one thing to note, and I did not have this problem, but some people have reported that the pins here that we're going to use, and we only need 4 of them, don't necessarily match what's going on here. But it's an easy check by sliding this cover right off. And then I hope you can see these pins are all labeled on the board. And what is on the board is accurate from what I understand on all of these, even some of the cheap clones. But they changed the pinouts on some, but not the cases. So if you're not sure, slide this thing off and check your pins here. And mine happens to be right, so don't worry about it. Back of the board, none of this stuff actually has to be plugged in. I just have the motors plugged in and got them out of the way already. And for this quick test, we're going to use a serial protocol and an Arduino just to see the motor spin. I've got my programming cable all wired up. This is how you will wire yours up, but don't connect your actual programmer to it just yet. We'll get to that. But before we can flash any firmware, there's a good chance your board came in read-only mode, so we need to unlock it. To do that, there's a couple of tools we need. The first is ST-Flash Utility, also known as ST-Link Tools. And we also need openocd. These are both command line utilities. If you're not terribly familiar with a command line, don't be worried. They're very simple utilities to use, and we're going to walk through the exact commands to type and to use. Of course, I'm using Ubuntu Linux, as is very common for roboticists. If you really don't want to use the command line, or you're using a different operating system, you can use, actually these instructions are deprecated. This utility is deprecated and replaced with the STM32Cube programmer that is available, I think, for all the operating systems. That works as well on Linux. I believe I had to sign up for a free account. I found it to be a little bit more cumbersome. Actually, I found it to be a lot more cumbersome than just using the command line. That's very easy. So that's what I'm going to show you how to do. And the command line utility also makes it easy to write the firmware. The recommended way to install ST-Link Tools is from the package repository of the used distribution. And if that's going to work for you, you're just going to need to do a sudo apt update, which I've already done, and then sudo apt install ST-Link-tools. Now if you get this result, like I do, where you're unable to locate the package ST-Link Tools, I'm using Ubuntu 18.04 and not the latest 20.04, so that's probably why it's not in my repository. And don't despair if that is the case for you. We're just going to have to use an alternate method of installation. And I found this tutorial that I will link in the description, and it seems pretty good. Now, I'm using an older laptop because I didn't want to accidentally have some dependencies pre-installed on the one that I've already been using and forget to tell you about them. So I'm using my old laptop. I've never done this, and hopefully it goes smoothly. So bear with me. The first thing we're going to have to do is make sure these are installed, and I'll just copy them together. Continue. Okay, it looks like that stuff's already taken care of. So now to download and build the libraries. This is he's just telling us to start in our home directory, which I can do there. And then now we're just going to make a directory and change into that directory, and that's where we're going to clone everything to. And then we're going to run some make commands. And I'm just going to try to run these all at once and hope there's no hiccups. And then whenever you copy and paste a bunch of commands together, don't forget the last one, you often have to hit enter. Move this over here a little bit. So now we're going to change directory into the binary directories, copy the binaries to user local bin. Then we're going to change into the lib directory and copy those into a folder called lib32. And then we'll just try to do those all together as well. Okay, so what we see here is the first commands were successful, but the last command, trying to copy to a folder called lib32, that's not a directory. Now, they're copying SO files, which are some library files, and if I were to check, so I did some sleuthing and found that SO files, as I thought, go in user local, and lib is a good place to put SO files the programs will look for. Now if we try to run that last cp command again, instead of lib32, we want to use user local lib, and that worked correctly. Here, yes, we need to copy the udev rules. Make sure we get in the right folder. Okay, now udev rules are kind of like pointers. They allow the computer to find the ST-Link actual physical device, and so we want to make sure these rules are in the right place. And the rules go to right there. etc/udev/rules.d. Now the program is not attached to the control board yet. I'm just going to plug it into the USB slot. Let's make sure we can see it. Here we go. Let's start. Now we can attach our ST-Link device using just these 4 pins: the SWDIO, the ground, SW clock, and the 3.3 volt. I made a little connector to make this easy for myself, and put some color codes on it. And that should be right. No, I almost forgot. We need to power the board for programming, and it's going to make some noises. I'm going to go back to Nicholas Voth's Hoverboard Firmware hack repository. He gives us a few choices to unlock via the command line. Oops. We're going to go ahead and install this openocd that I did not have installed. And this is why I'm using a computer that I've not done this before on. So let's try that command again. And just like that, STM32X is unlocked. So now we should be able to write to it. a reset or power cycle is required for the new settings. So what I like to do is disconnect it. Oops, we'll just hit Control-C to end that. And I like to physically remove power. We just finished installing ST-Link tools and openocd and unlocking our firmware. So now it's ready to accept an upload. Earlier in the video, we already set up the config.h in our hoverboard firmware. And so now we're somewhere here in the STM32 folder because that's where we were working. So now we're just going to change directory or CD back to the firmware home directory, which I put in my home directory. This little tilde means home right here. And compiling the firmware is really easy. With a command line, it's as easy as typing make. Hopefully there's no errors, and there does not appear to be, and that's awesome. So now we can actually flash the firmware. It's compiled into its binaries now, and we need to get it on the STM32 chip, the chip that drives our control board. ST-Link is already connected but not plugged into the USB. We're going to power up the board. Plug into our USB port. Now we're going to type make flash without pressing enter yet, okay? Make flash. Alright, so that's ready to go. And now we need to hold in our power button to the control board while it writes. Just make sure you hold that down the entire time it's writing. Press and hold, hit enter. And that's what we like to hear and see. Now, flash written and verified, jolly good. Let me unplug this because it's annoying, and for that to take effect, it usually requires a reset. Make sure you unplug your programmer also, or it's just going to sit there and be annoying. Now, at this point, the board is ready to go. You can take this. You can accept this and move on to the next video, or if you want to do a quick test with an Arduino if you have one handy, I'm going to show you how to do that now. Okay, if you've used Arduino at all, this is going to be pretty easy for you. You're going to start in the hoverboard firmware folder that you downloaded, and when you cloned it, one of the folders in there is called Arduino, and then Hover Serial, and then you're just going to open Hover Serial INO, and you don't have to make any changes here unless you changed baud rates or something in your firmware. Just compile and upload this like you would any other Arduino sketch, and then we will plug in the hardware. I used an R3 that I had laying around, but I think you should be able to use almost any Arduino board. The only wires we need are a ground and the TX wire. The TX from the Arduino going to the RX wire on the USART3, which is the right connector that used to go to the right accelerometer board, the side board. So we're just going to use the green wire and the ground because we're not going to receive any data back for this test, and I haven't found a need yet to use the red wire, which is 15 volts. And if I just power this Arduino board, and power the hoverboard on, and the wheels should just do some back and forth stuff. And now we know that our flash worked and the board will respond to serial commands. Now a note about the buzzer that's making all the beeps. It's occasionally handy. People find it very annoying. Some of it can be disabled if you look further in the config firmware. I believe what we're hearing is the reverse beep, and that can definitely be disabled in the config.h file that we modified. Another alternative is that can actually be removed. The first board that I got, the person had actually removed the buzzer and replaced it with an LED, so you could just watch the blinks for troubleshooting. And that's enough of that. And that's it for part 2 of the Hoverboard for Robotics series. Hopefully everything went smoothly for you, and you can now flash firmware to your own hoverboard controller. And now you get to make a choice. Do I go left? Do I go right? And the left hand, we have part 3 of the series, or part 3A, I guess. I don't know. But in the next video, I'm going to show you how to use these hoverboard controllers, set them up for a ROS-controlled robot, so it'll accept serial commands. And I'm also going to show you how to do the ROS side of that, the software package you need, how to set that up, prep it, and make the connections. And then in the right hand, part 3B, I guess, I'm going to show you how to control the hoverboard motors with a joystick or a pair of potentiometers. And that can be fun and can also be a useful tool that can be combined with the part 3A with the ROS controlled thing as well. And that's useful for either robots or it's just a really neat trick that you can create something you can ride around on. So for now, I'll say see you later. Go on back for parts 3A and 3B, and I've got a little video editing to do. I'll see you soon.